Hola, SAP developers. Welcome to this session, part of the TOEFL 2023 integration track. Before we start, I just want to let you know to please feel free to drop us your questions on the chat window, as we will be monitoring it and we will answer your questions there. I bet many of you are keen on learning about the Edge Integration Cell component, part of SAP Integration Suite. Today, we have Oliver Deckert, who is part of the SAP Integration Suite team, and will be sharing with us what Edge Integration Cell is and how it can support your hybrid landscape. Without any further delay, hola, Oliver, over to you.
Yeah, thanks, Antonio. Thanks for having me. So let's talk about Integration Suite hybrid integration as part of this DevToberfest here. I will start with some introduction to Integration Suite as for people who are not so familiar with that, who will ask what is Integration Suite and what is it used for. SAP Integration Suite is SAP's offering or SAP's platform for hybrid integration, for integrating SAP and non-SAP applications. Like you see it here on the left side, SAP applications, like cloud applications we have in our portfolio. It offers also government integration, business-to-business integration, or connectivity to third-party applications. So it tries to cover the whole spectrum for integration, what customers need in their specific environment. Now, Integration Suite also has seen quite some adoption with a lot of customers and has a considerable customer base already, and helps customers to drive their large scale or their flexible integration towards their landscape, but also for hybrid environments. Now, for hybrid environments, it's I will introduce the status quo, what we have right now, and then going into the direction as for the main topic, the hybrid integration part of it. Now, the current status, if you look at it from a customer perspective, you see two things. On the one side, you can adopt already SAP Integration Suite, our fully managed cloud offering for doing your integrations. It offers specific components like API management, also cloud integration for modeling integration flows. On the other side, if you have still a footprint in the on-premise space, having applications which run on-premise, so far you are you have to use another product called the SAP Process Integration, which is a product based on SAP NetWeaver, a standard on-premise product. What we did over the recent years is we made process integration kind of integration flow compatible, so that you can model integration flows for Integration Suite, which are able to run with certain restrictions, at least also on this process integration runtime. Nevertheless, it's two different products in the end, even if they have some compatibility layer. But the whole, let's say, runtime management and life cycle of the product is different, and that's why it's not, let's say, not the optimal situation we're having for the integration of on-premise application, and that's the one of the reasons why we are looking for providing a different approach where you can have actually one product. So it's going more into that direction, to have one product, one integrated product, and not having two different products. And this one integrated product should be able to cover then all the cloud integration and also the on-premise or ground-to-ground integration, how we call it sometimes, bringing in the notion of the ground that customers use for their in their environment. Now, the main paradigm will be to have still a cloud-based design time and configuration. So, if you will, control plane stays on cloud, and we will offer an integration studio which provides an harmonized view. Also, if you look at it in the past, the API management and cloud integration will come closer together into one harmonized offering. And this is then the cloud-based configuration for the complete integration suite. And for the on-premise parts, so for the actual ground-to-ground integration, we want to offer runtime components, which can then be used on that side, deployable on Kubernetes clusters, also with certain flexibility to choose for customers so that they can design integration flows and then flexibly decide, is this an integration flow I want to deploy in cloud? Is this a flow which I want to deploy on premise? And so give this, let's say, also increased way to use the technology in different aspects or in different environments, and have a better integration approach in general. Now, when we look at what are the reasons why customers really also pull for hybrid integration or for on-premise deployments, I mean, it's actually pretty simple. I mean, customers have still a considerable footprint in with on-premise applications. They have heterogeneous landscapes, and they adopt, of course, on the one side, they adopt cloud, but they typically choose an incremental approach or adoption methodology, and want to grow also in that respect, and so have more of a, you can call it maybe a conservative approach here, and still want to use their on-premise environments and their on-premise systems and integrate with cloud products and so on. There may be other reasons like security requirements in certain companies. There may be technical reasons like having latency or performance needs which are specific to a certain integration. Sometimes we have still legacy protocols which are not so easy to transfer to cloud, and some customers even might have still cloud availability concerns. So there are a bunch of reasons why customers still want to adopt or see a need for having really on-premise integration components, which help them to also to address all these different needs. Just a word, because we sometimes, or maybe to make this clear, what we mean also with customer environment in this context. If you see the picture here on the right side, this can be on the one side a real on-premise deployments, like having the data center of the customer, really an on-premise data center. But still we see more and more customers adopting also the flexibility of cloud, like a private cloud deployment, having a private network, which you can kind of rent from the cloud providers. And so you have your private network. It's like an extension to your local data center, if you will. And so you can also use this, having a controlled customer owned environment for your integrations. And this is also what we mean here as a candidate or as an environment for edge integration cell. Now, when we look into what I touched upon, the use cases which we see for edge integration cell is, of course, the hybrid integration for customers which still have the ground-to-ground integration requirements and want to still leverage their on-premise application and stay also with that for different reasons, what I had shown before. As we said, we want to have this cloud-based design time configuration approach using an integration studio that is part of the managed SAP offering. Then have the integration flows which are modelable or can be modeled once and deployed flexibly on cloud or on the edge, which is then also coming together with the API management, what I was talking before about the more aligned or harmonized approach, bringing API management and cloud integration closer together. This is then the API-led integration, what we also talk about here. That API design is the leading principle for integration, and this is also, let's say, better supported in this integration cell with the integration studio and bringing these both worlds closer together. A third or another use case which we also see evolving is that integration suite is also extended with eventing capabilities, event routing and things like that. And the edge integration cell can then be leveraged also for event routing to SAP applications on the edge and for making this event integration coming to life, so to say, also on the on-premise side. Now, from the how we will, let's say, position that and offer this edge integration cell is like when you look at it from a topology, how do we connect this to existing integration suite tenants and so on? It will be possible to have multiple integration cell instances connected to one integration tenant, so that you can have a flexible way to separate also different integration parts if you want, and also have the option to still use, of course, I mean, the cloud integration parts or the cloud integration runtime will not go away. So we will have a kind of a coexistence of both models in the same environment. So you can have one tenant having parts in integration flows running in cloud and other integration flows running on the edge. From a consumption perspective, model compatibility is very important, so that you can model once the integration flows and your integrations or APIs, and then flexibly use in the target environment like you want. For the edge, as we said, I mean, we'll have a closer look at that, but we will have a Kubernetes environment. So the runtime components that will be offered are workloads are configured and deployed in a Kubernetes on top of a Kubernetes runtime. And also the customer will bring certain additional components, like having a database storage on the edge, and bring this as part of the edge integration cell operated by customer. From a lifecycle management perspective, we will have an offering where customers can control the lifecycle of the edge instances, like doing installations, upgrades on their own. So compared to the cloud model, right, where the full management is done by SAP, and on the edge, it's in the control of the customer, where the customer is then in the driver's seat, if you want, to adopt new versions, and we will provide the tools to make this happen. Now, we started with a beta product end of last year. It ran over the year 23 with a selected number of customers. So it was an invited beta, so around 30 customers adopting the product, testing it, and so on. And the scope was like, from a Kubernetes perspective, we had the offering on Azure and Amazon. I mean, if you think about this on-premise notion, it's then in this customer-owned IaaS space, so customers having the logical extension to cloud providers. So they have their own Azure subscriptions, Amazon accounts, and deploy the edge integration cell into their environment based on the Kubernetes flavors of the respective platforms. So on Azure, that's the Azure Kubernetes service, and on Amazon, it's the Amazon derivative or the Amazon way flavor of the Kubernetes environment. And so these customers were able to deploy integration flows with a limited set of policies, and were also, let's say, testing mainly with a focus on cloud integration, because this was the major part of the beta delivery. Good. Let's look at high-level building blocks of the offering. We touched upon, I mean, certain parts you already have seen, like in the upper part, the integration suite, API management, cloud integration, event mesh, and things like that. So these are the main integration suite parts. Now, for the lifecycle management, what I was talking about, there's a new component provided by our lifecycle management teams, which is called the Edge Lifecycle Management, which was specifically also built for such hybrid integration or such hybrid applications where you have certain parts in cloud and certain parts running on the edge. And like you see it here, there's the different parts. We have a so-called orchestrator, which mainly, like the name says, is able to orchestrate the lifecycle actions like installation, upgrades, and all of that. It also has certain parts on the Kubernetes side, so it deploys certain services also on Kubernetes, let's say, to make the lifecycle actions happen on the Kubernetes level. It brings also a cloud connector to have a secure channel to connect from cloud to edge. And also the most or an interesting part is the link to the repository-based shipment channel, which is the main, let's say, delivery way to deliver images, container images for Kubernetes workloads. And so that, let's say, our solution is then kind of split into different images, container images that are delivered via this repository-based shipment channel. And the Edge Lifecycle Management, let's say, deploys the images into the Kubernetes cluster and, let's say, builds up the Kubernetes resources based on Helm. Helm is a packaging manager for Kubernetes. And so the solutions that we offer are packaged as Helm charts and so are then used by the orchestrator to deploy the actual Kubernetes resources. And this is in the green box. This is then our solution. Technically, we have different parts, which is shown here, only the most important parts. Like we have a component called the policy engine. This is more for API management policies, execution. We have a component called the worker, which is more the execution runtime for integration flows. And we have also an event broker for handling events on the edge, and also in combination like for the event routing to cloud and back, which we have also seen before. Now, when we kind of zoom in from this higher level perspective into Kubernetes level, then this is more like you see it here. The right side, we have the cloud parts of the integration suite, so business technology platform, where we use also certain cloud services like XSUA for authentication, the object store, that's part of the BTP environment, or secure store for sharing credentials and things like that. We use the destination service for connecting to the edge via cloud connector, for example. And so these there's a certain dependency to these cloud services. Besides these dependencies, we also work a lot with synchronizing data to the edge, and replicating also data, so that the cloud services are needed for certain functionalities, but in the end, most of the data is cached locally and synchronized to the edge, so that you can have a more autonomous processing on the edge and do not need to rely on cloud services, also for the execution of integration flows and the like. Now, when we look at the left side, you see a normal kind of Kubernetes cluster with worker nodes, where you have Kubernetes resources being deployed in different namespaces. These are these white boxes. Like we have a namespace for edge lifecycle management. So this is the component which handles all the lifecycle actions, deployment, upgrades, configuration of the edge instances. It comes with certain with a monitoring stack, logging stack for allowing cloud monitoring or cloud-based monitoring also, and log monitoring for operating the solution, because we in our model the customer is let's say in the driver's seat for operating the left part of the edge integration cell, and then needs to handle using this edge lifecycle management all the parts or the components on the Kubernetes level. On the left side, on the lower part, we have the edge integration cell solution with components which are more for the runtime execution, like policy engine worker. We have certain backing services in the stack, which are more like database data store. So we use a Postgres database for storing runtime data or monitoring data. We have a Redis instance for caching of certain objects for the execution of policies. And then finally, we have a Solace broker, which is the event broker for handling events on the edge. And of course, this is backed up by persistence. So we need persistent volumes for storing data on the edge. Part of the edge lifecycle management is also a bootstrapping tool. So if you start with a let's say a plain Kubernetes cluster, it starts with running a bootstrapping tool. And the bootstrapping tool then in the end hooks up the Kubernetes cluster to the cloud tenant, so that you get all these nice arrows from left to right, so that the edge instance is connected to the cloud tenant, and the lifecycle management can then be used to deploy, configure the edge instance for then in the end enabling the customer to also deploy integration flows and also model APIs on top of that. As I said in the beginning, the leading paradigm is having a cloud-based design time configuration. So still the cloud tooling will be used for modeling integration flows and APIs. We will have an operations cockpit provided for customers to operate the edge part together with these edge lifecycle management, so to say. In the end, all the tools that are needed for customers to operate the whole environment as the hybrid, let's say, operations model is now then also inherent in this offering. Good. From a Kubernetes perspective, when we look at how we approach let's say the heterogeneous offerings that are in the market, of course we started with trying to get some feedback from customers. What favorites, what platforms do they use, what do they need, and in the end, and when talking to customers, there are some dominant platforms, of course, but it's not that it's only one platform that's being used by all platforms. But of course, it's like an heterogeneous world, and so different offerings are like different. For like some customers are more in favor of Azure, other customers are more in favor of AWS, and it's similar on the Kubernetes front. Then we sort of okay, what could be our approach? Like looking at products which have a similar background, like data intelligence, the on-premise part of it. They went with a platform availability metrics, offering their product on most of the on the 4 dominant hyperscalers and 2 additional offerings, which is OpenStack and SUSE Rancher. We also thought about Gardener, but Gardener is not in the position, so to say, to be offered as an on-premise Kubernetes platform right now. And the conclusion for us was that we also will go with the platform availability metrics, and we'll start, or the target platforms will be the hyperscalers, Azure and Amazon, and also the more, or yeah, you can call the most used or the predominant Kubernetes on-premise platforms, which is the SUSE Rancher and Red Hat OpenShift container platform. And so in that direction, we hope to, let's say, that we can cover most of the customer use cases. Probably we will have extension for Google Kubernetes Engine as the next candidate. And then we will need to, let's say, get customer feedback also in this direction, what platforms they pull for, or other, let's say, needs they have, and then we'll think about extension of the platform in future. Good. I think that was most of the run through the cloud integration or edge integration cell for hybrid integration. And so we would probably have time for some questions also.
Thank you very much, Oliver, for sharing your expertise in this session. I do have a couple of questions for you, and maybe just to clarify a couple of things. So the Kubernetes environment, apologies, the Kubernetes environment in the end, like either if it's in the infrastructure as a service provider, or if you end up deploying it eventually, for example, to a SUSE Rancher on-prem, like in your own data center, it is all managed by the customer, right? Which ends up meaning that the updates will need to be applied by the customer itself on this Kubernetes cluster. Is that correct?
Yes, that's correct. I mean, of course, it's like the customer manages the Kubernetes environment, like you rightfully said. Of course, in the cloud platforms, Azure and AWS, they offer a managed Kubernetes environment, right? So it's a kind of a simplified approach. So you don't have to care for the whole cluster. Typically, only the control plane of the cluster is managed by the hyperscaler itself, and so it's more simplified. But in the end, customers need to take care for the Kubernetes updates and also then for the edge integration cell updates on top.
Yeah, and I guess that means that they need to keep up to date their instances, right? Not like I don't know. Traditionally, when you have process orchestration, process integration on-prem, it's like you wait a long time before updating. If this is a cloud speed, it means that you will need to basically keep it up to date. I don't know, every month or every couple of months or something like that, right?
Yeah, that's correct. So our go-in assumption is that we deliver updates at cloud speed. That means on a monthly basis, and that customers should also follow and consume in the same cycle. So when we release a new version, then the customer will have kind of 4 weeks time to adopt the latest version and consume the version. And of course, customers will need to follow this approach because call it the long maintenance cycles from the past are really quite hard to stand, so to say, in the long run. And so we will need to, let's say, motivate customers also to follow us in that journey with more frequent adoption. Of course, if you compare it to the old times, like, I mean, before I talked about having a NetWeaver-based integration product, where the delivery was also quite with huge support packs, and that was also one reason why customers were not so keen in adopting these products or these newer versions. And of course, in our approach here, we will have quite a let's say, I would say a better to digest update stream or update cycle with smaller updates and having, let's say, also lowering the risk for customers. And we will come also with, let's say, Kubernetes support. It will help us a lot going forward with operating these environments. We will offer, for example, going forward, a rollback mechanism, which is not there in the old kind of world. So you have more options for simplifying the life and also the consumption of updates.
I understand. So you mentioned just now Kubernetes environment, which can be, I don't know, can be a challenge to sort of keep up with it, right? But I guess from an integration developer perspective, it's transparent for you, right? Like obviously someone like from a sort of basis team will end up taking care of like the deployment or the creation in a Kubernetes cluster. But then from an integration developer, it's like you basically access your integration studio, you deploy your integration flows from the integration studio in the cloud, and then you end up selecting where it goes, and then you will end up deploying it, for example, to your edge integration cell node, and even, for example, components. I remember you mentioned something about syncing data, and like, for example, in this case, an integration flow which ends up being synced to the node, but also like something like credentials, right? When you end up creating a credential in the cloud, then it will automatically like sort of sync it across to your nodes. Is that correct?
Yeah, that's correct. So as we said, we have this cloud-based configuration, and also credentials are maintained in cloud and then replicated to the edge automatically without any interaction, so to say. But of course, the customer still needs to or what we saw also during the beta is that we will have the separation in the customer organizations, that kind of the basis team, if you look at it from the on-premise world more, then you typically have the basis teams caring for the operating system and databases and things like that. And they are the ones now which take care for the Kubernetes environment. So you can see that let's say this approach, going forward as well with that. And then the basis team is then more in this technical Kubernetes management, and the integration developer uses the integration studio on top for modeling the integration artifacts.
Makes sense. And in the end, it's one integration suite tenant, multiple, potentially multiple edge integration cell instances,
yes.
Correct? But then there is a one-to-one relationship between a Kubernetes cluster and an edge integration cell instance. Is that correct?
Yes.
Okay.
Yes. One Kubernetes cluster is handled on this level, like it's called an edge node. So it's made up as one instance. Yes.
Okay. Well, that is clear to me. So thank you very much, Oliver. And I also want to thank the viewer, for joining the live event, or if you're watching the recording of this event. So just a reminder that there is plenty for everyone to learn during the Torfest. So make sure to check out all the sessions that are part of the event. So thank you.
Yeah, thanks for having me.
Bye.
Bye.